Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 13 video from the chapter of Heron's formula, I will be discussing about an interesting result based on the area of a trapezium and some property of a triangle. As you can see in the thumbnail, when we extend the non-parallel sides and when they intersect at a point O, then what will be the ratio of the triangle AOD and the trapezium ABCD. This I will discuss in this video. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so we have a trapezium ABCD where the parallel sides are AD and BC, and the length of the parallel AD is X and length of the side BC is Y. Now obviously from this figure we can see that Y is greater than X, that is BC is the longer parallel side and AD is the shorter parallel side. So when we extend the non-parallel sides AB and DC, so I am extending from the shorter parallel side. The shorter parallel side is AD. So I am extending the non-parallel side BA along the vertex A, and I am extending the non-parallel side DC along the vertex D. Let's say they intersect at the point O. They will intersect at the point O. So we have the triangle AOD and of course the trapezium ABCD. Now the only information given is the length of the parallel sides of the trapezium ABCD. We have to find the interesting results that we will see are the ratio of area of triangle AOD and area of the trapezium ABCD. What will be this ratio, or even primarily this is the main result that we will see. Also we can find I think this is the main result. What will be the ratio of the triangle AOD and the trapezium ABCD? Now the result that we will come up that we will derive is heavily based on this concept of a triangle, that if you have any triangle, let's say this is any triangle ABC. Now if you draw a line, let's say parallel to one side, let's say I am considering a line drawn parallel to side BC, and let's say they intersect. So they intersect the other two sides at the point P and Q. This concept I have also discussed in the previous video. If you have watched the previous video, then you will know this concept. So PQ is a line drawn parallel to the base BC. Then the ratio, then this line PQ is will divide the sides AB and AC in equal proportion, which means that we will have AP by AB will be equal to AQ by AC, and also we will have PQ, this is equal to PQ by BC. Basically this parallel line PQ has formed two similar triangles. The triangle PAQ and triangle ABC are similar. They are not congruent, they are similar. Similar triangle means they look their shape is same but the size is different. Then we will have this relation. AP by AB will be equal to AQ by AC and will be equal to PQ by BC. We will use this concept. Okay. So what will I do is, so we have this. Now to find the area of the triangle AOD, I know the base. I can consider AD as the base, but I need to know the perpendicular distance from O on AD. So let's say from the vertex O, from the point O, I am drawing a line perpendicular to BC. Let's say this be a line perpendicular, let's say this be OT. Let's say OT is drawn perpendicular to BC. Obviously, it will also be perpendicular to AD because AD and BC are parallel. AD is drawn parallel to BC, and AT is drawn perpendicular to BC. This will imply, let's say, OT intersects the AD at the point, let's say P. So we will also have OP perpendicular to AD. Okay. So then so then let's see what will be the area of the triangle AOD. It will be equal to half AD multiplied by OP, and AD half into AD into OP. And what is the area of the trapezium ABCD? Area of the trapezium ABCD is sum of the parallel sides, which is x plus y, half into x plus y multiplied by the altitude. For the trapezium ABCD, the altitude is PT. It is PT. Okay. Now we have to find what is AD and OP. We need not find the exact values of AD, OP and PT because eventually we have to find the ratio of the area of the triangle AOD and trapezium ABCD. Now see, in triangle in the BOT is a right angle triangle. In triangle we see that AP is parallel to BT. Now the concept that I discussed just now, that if ABC is a triangle, if the line PQ is drawn parallel to BC, then PQ will divide the sides AB and AC in equal proportion. It is also the other way around. Also we can say that if a line is drawn PQ such that the point P and Q is dividing the side AB and AC in equal proportion, then PQ will be parallel to BC. Okay. So now we see in the triangle BOT, AP is parallel to BT. So this will imply we will have, we can say we will have we will have OA by OB. OA by OB should be equal to OP by OT, OP by OT. Okay. Now in triangle BOC, we see that AD is parallel to BC because AD is already parallel to BC because they are the parallel sides of the trapezium. So in triangle BOC, we see AD is parallel to BC. So this will imply that OA by OB will be equal to AD by BC. OA by OB will be equal to AD by BC. Now AD by BC, AD we know is X and BC we know is Y. Okay. So then we can say we from triangle BOT we saw OA by OB is equal to OP by OT, and in triangle BOC we saw OA by OB is equal to X by Y. So we can say OP by OT is equal to X by Y. OP by OT is equal to X by Y. Okay. This implies what is OP? OP is equal to X by Y multiplied by OT. Okay. Okay. OP, OT. Fine. Now, what will be then the area? Then the area of the triangle AOD is equal to half, we can consider AD as the base, and the corresponding height altitude is OP. This is equal to, what is AD? AD we know is x, and what is OP? OP is so this is x by 2 multiplied by AD. AD is half into AD is x by 2 and then multiplied by OP. OP is x by y multiplied by OT. So this is x square by 2y multiplied by OT. This is the area of the triangle AOD. Okay. Now, okay. Now let's see what is the area of the trapezium ABCD. Area of the trapezium ABCD we know is half into x plus y multiplied by PT. So this is x plus y by 2 multiplied by PT, where PT is the altitude of the trapezium, because PT is the perpendicular distance between the parallel sides AD and BC, as OT is perpendicular to BC. Now what is PT? PT we can see is OT minus OP. This is equal to x plus y by 2. PT we can see PT is OT minus OP. OT minus OP. PT is equal to OT minus OP. Okay. So this is equal to x plus y by 2 multiplied by, what is OT? What is OP? OP we saw is x by y multiplied by OT. So this is OT minus OP is x by y multiplied by OT. Okay. This after simplification is x plus y divided by 2. I can take OT common. If I simplify this, this will be OT multiplied by y minus x divided by y. This I will multiply y minus x and x plus y, and it will be applying the formula a plus b into a minus b is equal to y square, ax square minus b square. It will be y square minus x square multiplied by OT divided by 2y. Okay. So now what is this implies? What is the ratio then? Area of triangle AOD divided by area of ABCD is equal to, area of triangle AOD was x square. This was the area of the triangle AOD, x square by 2y multiplied by OT divided by area of triangle, area of the trapezium ABCD is y square minus x square by 2y multiplied by OT. So if you simplify this, OT will cancel out, 2y will cancel out, and it will be x square by y square minus x square. So you see, this is an interesting result, that when you extend the non-parallel sides in a trapezium, obviously you can extend you have to extend the non-parallel sides along the shorter parallel side, because if you try to extend the non-parallel sides along the longer parallel sides, they will never intersect. So extending the non-parallel sides, let's say they intersect at some point, and then we can see in this diagram that there is an interesting result of the ratio of the area of the triangle AOD and the trapezium ABCD in terms of x and y, where x is the length of the shorter parallel side and y is the length of the longer parallel side. Maybe this result could be used to frame any question based on the area of a trapezium, and also this concept. This is a very, very important concept. This concept, this ratio and the triangle, a line, if PQ is a line parallel to the side BC, then the line PQ is dividing the sides AB and AC in equal proportion, and the other way around is also true. If PQ is a line such that it is dividing the side AB and AC in equal proportion, then it should be parallel to the other side, that is BC. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next 2-3 videos I will try to solve 5 problems in each set based on the area of trapezium, quadrilateral, and some other. These problems could also incorporate the concept of area and perimeter of square, rectangles, and parallelogram. So please stay tuned for these upcoming videos where I will be solving problems. I am ending the video here. Thanks for watching, and until the next video, take care and bye.